In this video, I am going to solve the 16th problem from chapter 17, Waves Part 2. Organ pipe A with both ends open has a fundamental frequency of 425 Hz. The fifth harmonic of the organ pipe B with one end open has the same frequency as the second harmonic of the pipe A. How long are a pipe A and pipe B? Actually, this question is a little bit lengthy because we have to consider three cases. In the first case, actually you have two pipes. One is pipe A and one is pipe B. The pipe A, both ends are open, but in the pipe B, one end is open and another end is closed. Clear? So, and also they said the fifth harmonic of the pipe B has the same frequency as the second harmonic of pipe A. So we have to consider three cases. So what I am going to do for finding the length of pipe A and pipe B, I am going to consider the three cases. What are the three cases? In the first case, I am going to consider the organ pipe A with both ends are open for the fundamental frequency. What is fundamental frequency? The fundamental frequency stands for N, which is equal to 1. Okay, so let's start here. So I'm going to take, this is my organ pipe A. So its length, better I can write here, its length here from here to here is LA. LA. This is organ pipe A length. And they say it has a fundamental frequency. That means it has only one. N is equal to 1, which is nothing but the nodes is 1, right? And both ends are open. So if you have both ends are open with N is equal to 1 value, you have to draw the wavelength, right? The waves will be going like this. Clear? Now what I am going to do, I am going to write what should be the value of the lambda for this case. So let's take, this is our first case for organ pipe A with both ends are open for the fundamental frequency. What is the fundamental frequency here? The fundamental frequency here they mention as 425 Hertz, right? Actually fundamental stands for N is equal to 1, right? So better I can write this is F1. Now I am going to calculate how many lambdas are here. So the length, the total length in organ pipe A, which is equal to how many wavelengths are there? In the previous chapter I explained, in each loop you have 2 quarters of lambda, right? But here you have only half here, half here. That means lambda over 4 here, lambda over 4 here. So what's the total? 2 lambda over 4 you have. So this is nothing but lambda 1a, right? Because we consider for n is equal to 1 because they mentioned here as fundamental, right? Okay, now we can cancel this. So by that this becomes 1, this becomes 2. Therefore lambda 1a, which is equal to 2 times of LA, right? Clear? Okay, now what I am going to do, I am going to find what should be the speed. As we know the rule for the speed which is equal to frequency, that means the fundamental frequency in organ pipe A multiplied by the lambda in organ pipe A, right? For the fundamental, for n is equal to 1, its frequency, and for n is equal to 1, what should be the lambda? Lambda 1a, right? And by using this, I am going to rearrange this equation in terms of frequency. By that, this equation will become f of 1a, which is equal to v over lambda of 1a, right? Clear? I am going to take, or better we can substitute the value of the lambda here. Now what I am going to do, I am going to take this lambda 1a and substitute here. By that, what will happen? The equation will become f of 1a, which is equal to v over 2la. So I'm going to take, this is my first equation for the first case. So let's write, this is our first equation. Okay. In the second part of the question, what they mention, the fifth harmonic of the organ pipe B with one end open has the same frequency as the second harmonic of the pipe A. So now what I'm going to do, I'm going to draw the same similar type of diagram for n is equal to 2, because they mentioned here your fifth harmonic of pipe B has the same frequency as second harmonic of pipe A. So one more time, I'm going to draw the diagram for pipe A, because here the pipe A is both ends are open. And for the second case, I'm going to consider n is equal to 2, because they mentioned this is second harmonic, right? So I'm going to draw the same type of diagram for n is equal to 2. So two nodes, right? So if you draw the wave, it will be passing through like this, right? Organ pipe A, and for this I'm going to find what should be the wavelength. So that means LA, which is equal to, how many lambdas are here? Here lambda over 4. In a loop you have 2 quarters, right? That means here lambda over 4, here lambda over 4, and one more lambda over 4 here. So what's the total? 4 lambda. This is the second harmonic, n is equal to 2, right? So I can write 4 lambda 2a over 4, right? So by that we can cancel this. Therefore lambda 2a, which is equal to LA. And now I'm going to find the formula for the speed. Therefore speed, which is equal to frequency for the second harmonic, that means f2a, multiplied by lambda 2a, it's a respective wavelength. And I'm going to rearrange this equation in terms of frequency. Therefore the frequency to a, which is equal to v over lambda to a, and I'm going to take this lambda to a and I'm going to substitute here. By that, this equation will become f of 2a. Don't get confused about this 1a, 2a. 1a stands for n is equal to 1. 2a stands for n is equal to 2. Okay, and here a stands for pipe A and pipe B. Pipe A, both ends are open. Pipe B, one end is open, another end is closed. Clear? So don't get confused about that. So here n is equal to 2. So therefore the frequency for n is equal to 2 for organ pipe A, which is equal to v over, so in place of lambda 2a, I'm going to substitute this answer as LA. So I'm going to take, this is my second equation, right? Okay. So far we finished two cases, right? The first case, in first case what we did? In first case we did for the fundamental n is equal to 1 for pipe A, and in the second case we did n is equal to 2 for pipe A, because why? They mentioned here the fifth harmonic of pipe B has the same frequency as second harmonic of pipe A. That's the reason we took the pipe A for n is equal to 2, right? Okay, now what I'm going to do, let's we calculate for the fifth harmonic for pipe B with one end is open, another end is closed, right? So we have to draw the similar type of diagram for that case. Okay, so this is our third case, and here the total length is organ pipe B, right? Okay, for B, how many harmonic? N is equal to 5, right? All the times your nodes will be happen only in the closed end, right? So 1, 2, 3, 4, 5. So every time in the open end you will get the antinodes, right? So keep this information because we already studied these things in the theory, right? So I have to draw the wave. See here in open end we got only the antinodes. So if you complete a loop like form, clear? Okay. Now this is our pipe B, and how many n we have here? N is equal to 5 because it is fifth harmonic. So n is equal to 5. So I'm going to frame the equation for the lambda here. So let's we calculate what should be the value of lambda in this case. So length pipe B, organ pipe B, which is equal to how many lambda you have? You have loop. That means here, if you split, you have 2 quarter of lambda. Here also 2 quarter of lambda. Here 2 quarter of lambda. So here also 2, and finally you have 1. That means 1, 2, 3, 4, 5, 6, 7, 8, 9 lambda 5b over 4. Why I write 5 here? Because n is equal to 5. N is equal to 5 stands for 5 nodes are here, right? And why I just put b here? Because this is the pipe b. Clear? Okay. Now I am going to frame the equation for the speed. So therefore, okay, better we can convert this in terms of lambda. So therefore, the wavelength for n is equal to 5 for pipe B, which is equal to 4 times of LB over 9, I think right? This one, okay, over 9, that's it. Now I'm going to find what is the speed of the wave here. So speed of the wave, which is V equal to F of fifth harmonic for pipe B, lambda of fifth harmonic for the pipe B, right? Therefore, F of phi B, which is equal to V over lambda of phi B, and I'm going to take the lambda, I'm going to substitute here. If you substitute, what will happen? F phi B equal to V over, this will come here, and this 9 will go to the top, right? So I can write one more steps. So 4 LB over 9, and this 9 will go to the top. By that, this equation will become F of phi B, which is equal to 9V over 4 LB. That's it. We finished for 3 cases, right? I'm going to take, this is our third equation. So let's we see the equation 1, 2 and 3 one more time, okay? So the first equation is for the fundamental frequency for the pipe A. The second equation is the frequency for the n is equal to 2 for pipe A, right? And the third one is for the frequency for the pipe B for fifth harmonic, right? Okay, now we are going to find what should be the length of pipe A and pipe B, right? Okay, for finding the length of pipe A, I am going to take the equation 1. Better we can write the equation together, and then that will be easy for our case. So let's we write all the equation together. So first equation I am going to write here as, what is our first equation? F of 1A, which is equal to V over 2 of LA. This is our first equation. What is our second equation? F of 2A, which is equal to V over LA, right? And our third equation is this one. So F of phi B, which is equal to 9V over 4LB. Okay, now it's very easy for us. For finding the length of the pipe A, I am going to take the first equation. From equation 1, what is our equation 1? F of 1A, that means fundamental equation frequency for the pipe A, which is equal to V over 2LA. And I'm going to rearrange this equation in terms of length of the pipe A. Therefore, length of the pipe A, which is equal to V over 2 multiplied by the fundamental frequency for pipe A, right? And we have the value for the V, right? What is the value for the V? Which is speed of the sound in air. It's a constant. Because here the organ pipe, you can emit the sound by blowing the air there, am I right? So here the speed of the constant value. So in this place, I'm going to substitute 343. So 343 is the speed of the sound in air over 2 times of, what is the fundamental frequency? What is the fundamental frequency? They mentioned in the question, I think it's a 425, right? Better we can go back and just have a look one more time. So I think the fundamental frequency is 425 hertz, right? Fundamental, I already told you many times, am I right? Fundamental means it stands for n is equal to 1, right? So I have to substitute here 425. So let's see what is the answer for this. 343 over 2 multiplied by 425. The answer is 0.4035. So I can write as 0.404, right, meter. So we got the answer for the first part. For finding the second part, what I am going to do, I am going to compare equation 2 and 3 because they mention the fifth harmonic frequency of pipe B has the same frequency as a second harmonic of pipe A, right? The second harmonic frequency of pipe A. So what I am going to do, I am going to compare equation 2 and 3 for getting the answer for the second part. Clear? First part is very easy. We can directly choose the first equation, we get the answer. Clear? For getting the answer for the pipe B length, I am going to choose these two equations because they clearly mention this frequency is equal to this frequency, right? F of 2A equal to F of 5B. That means I have to equate the right hand side of both equation, right? So that means speed over LA, which is equal to 9V over 4LB. Clear? I can cancel this speed with speed. So by that I can rearrange this equation. So therefore I'm going to take this to the left hand side of the numerator. By that this equation becomes 4LB equal to 9 multiplied by LA, right? Therefore we are going to find the answer for LB which is equal to 9 LA over 4. LA value we already got from the first part, so I am going to take this data here and substitute here. So 9 multiplied by 0.404 over 4. Let's see what is the answer. 9 multiplied by 0.404 over 4. It's 0.909. What's the answer of the length of the pipe B? Pipe equal to 0.909 meter. Clear? Actually, this question is a little bit lengthy, but we are exactly using what they gave in the question. Am I right? So please read the question and try to substitute, try to apply the rule one by one. And finally, what we need, we can just use for our calculation. Clear? Clear? So this is the answer for A and this is the answer for B, right? That's it. Thank you.